Hello everyone. In this video, I'm going to teach about the modeling infiltration capacity. So after you've collected your data using the infiltrometer, what are you going to do with the data that you got? Okay, so you can plot your data either in this form, like this, in the red form, the small f versus time, or you can also plot it in the mass curve type, like this one. Okay, and you can also use some equations to model the infiltration capacity. So I'm going to touch on two types of equations, which are Horton's equation and also green M. But there's only one example in this video, which is only Horton's equation. And you can find some other equations example in the Subramanya book that I recommended in class. Okay, so what is Horton's equation? Okay, so this is the equation where you can find infiltration capacity by using all this data. Okay, you need to have your F naught, where it is actually initial infiltration capacity at time 0. Sorry, this one. Okay, and then you need to find also the FC, which is the final steady state infiltration capacity. Okay, you can find this from the data that you got from your infiltrometer. Okay, and then you also need this Horton's decay coefficient, which actually depends on the soil characteristic and the vegetation cover. Okay, so from that equation just now, you can actually simplify it like this. Okay, you can move around that equation so that you can find the intercept is actually this value, and from this value you can get the Horton's decay coefficient, okay, from that slope of the line that you've plotted. Okay, we will see how we are going to get these values in the next example. Okay, so let's say we have this example, okay, where you've collected the data from the infiltrometer, and this is what you get. Okay, after 130 minutes, okay, you got all this data. This is actually cumulative infiltration depth. Okay, and then from this data you are required to get to do all this, where you have to plot infiltration capacity versus time, infiltration capacity versus cumulative infiltration, and also cumulative infiltration versus time, and then you have to obtain the best values for the Horton's infiltration capacity. Okay, so from this data you can actually get the FC, F naught, and KH. Okay, so in my slides I've given all these answers, but I'm going to explain it to you by using Excel. It might enlighten you a bit on how do you get this data. Okay, so let's say from the question just now, okay, you are given the cumulative time in minutes, and you are given the cumulative depth in centimeters. Okay, so for you to get the rate for each incremental time here, okay, you have to do the calculation between the differences in this interval. Okay, so the first thing is, okay, because this is the first reading, just imagine when you pour in the water into the infiltrometer, it will decrease by time and you will get this value, right? But then you will need to get each incremental depth between the time interval. So all you have to do is actually just minus this value with the cumulative depth before this one minus this one. So this is the formula, C4 minus C3, like this. Okay, then just copy that. Okay, it's easy by using Excel, but when you do hand calculation, it's going to take a lot more time than this, of course. Okay, then since it is asked here, it's actually easier to get the rate of infiltration in terms of centimeter per hour. Okay, so you have to convert your time here. Okay, this is in minutes, convert it into hours. Okay, so just divide by 60, of course, this one. Okay, so but this is going to be in cumulative. Okay, so this is cumulative hour, cumulative time. Okay, just ignore this for now. I've inserted the formula and the data here, so it's going to plot automatically. Okay, so this is the time. Okay, then how do you get this one? Okay, because the hint is actually in the unit. Okay, it's centimeter per hour, so all you have to do, okay, is just divide this one with this one. Okay, but remember, this is the cumulative time in hours, so you have to find the difference, the interval difference between this one and this one. So that's why the formula is like this. Okay, d4, this one, d4 minus g4 minus g3. Okay, so that you can get the interval between this time. Okay, because as you can see here, the difference is 5 minutes. Here is 5 minutes, here is 10 minutes, this is 20 minutes, so it's going to be different for every row. Okay, so when you plug in the formula here, just drag it down, then you will get your infiltration rate in centimeter per hour unit. Okay, and if you remember, you are also asked in the question, okay, that you need to plot cumulative infiltration, this one. Okay, so you also need to have this column, this ln times infiltration rate minus the infiltration capacity, so that you can get the Horton's equation, which is the KH and also the slope. If you remember this one, hold on, this one. Okay, because you want to get this slope and this intercept, so that you can get this value, so that you can solve for f0. Okay, and this KH, so that's why there's another column here. Okay, so how do you get this? Just plug in the data like this. Okay, ln this one fp, okay, minus fc. Okay, so the question is what is fc? Can anybody guess what is fc? Okay, so if you look at the data here, after minute 110, okay, the data recorded for the incremental depth, okay, are the same, 1.08, and the infiltration rate is the same. Okay, so it means after this time, okay, there are no more increment in the infiltration rate. So this is actually what we call as the final steady state. Okay, where the rate does not change anymore. Okay, so we will use this value, okay, and plug it in here, this fc here. Okay, this is an Excel tip. Okay, if you want to fix your cell value like this, because I'm using this value here, okay, you should put this dollar value, okay, here, so that when you drag your cell, it won't move. Okay, that is just one Excel tip that you might find useful in the near future. Okay, if not, if you didn't put this dollar value, then when you drag this, okay, this cell will keep on moving downwards. Okay, it will copy the move of the cells. Okay, so that is just one tip. Okay, so now moving on to the our question just now. Okay, so for this exercise you should plot all these three things. Okay, infiltration capacity versus time, capacity versus cumulative infiltration versus time. Okay, so what I've done here is plotting all this. Okay, I combine question 1 and 3 here. Okay, and then I did a separate one for question 2, which is to plot FP, small FP, infiltration rate versus the cumulative infiltration, like this. Okay, and then also for question B, you have to obtain the best values for the parameters in Horton infiltration capacity equation. So if you look at the equation, okay, you've got your FC, okay, from the table, okay, and then you have your time, which can change. Okay, this is okay. So what you need to determine now is just F naught and this KH. Okay, the initial infiltration capacity at t equals to 0 and also the Horton decay coefficient. So now moving on to this one. Okay, so that's why you need this column. Okay, so that you can plot the infiltration rate versus the ln FP minus FC, like this one, when you rearrange this equation. Okay, then you can get the intercept is equals to this one. Then you can solve this, okay, for F naught, and then the slope is actually the Horton's decay coefficient. So for this one, okay, so you just plot this value, this ln versus FP, and no, it's actually FP versus this column versus this column. Okay, this is Y, this is X. Okay, then add in the trend line. This is just a linear trend line. Okay, so I've added a linear trend line here, and then just display the equation, and you can just also display the R square here. Okay, now you get this one. You get this equation where KH is this one. Okay, this one, and ln F naught minus FC is okay, sorry about that. Okay, okay, so from the equation you can see that this is KH, this is KH, okay, and this is the ln F naught minus FC. Okay, and then just solve that so that you can get your F naught like this. Okay, since we already know the FC is 3.24 from the table. Okay, just solve it like this, then you will get your F naught. Okay, then that solves everything. You've obtained your KH, you know your F naught, and you know your FC. Then you will get all the parameters that you are supposed to have for you to be able to solve for FP like this. Okay, so that's it. Okay, see you in the next part.